So before we start our class, I would to remind you about our first assessment. That is final assessment one. That uh, on this Saturday. So make sure you are ready and available on that day. And if there is a problem, please let me know. Okay, jangan diam seribu bahasa ataupun MIA, missing in action. Okay, but so and I only accept the reasonable reasons. Okay, unreasonable reasons uh, will not be accepted. Maksudnya wajib ambil, wajib ambil, tetapi uh, sekiranya tak dapat ambil, okay, bukan sekiranya tidak dapat ambil lah, tapi kalau ada apa-apa masalah, first let me know, and then after that kita akan fikirlah apa yang sepatutnya, tetapi dengan reason yang boleh diterima. Okay, noted? Boleh?
Madam. Boleh, madam.
Okay, so mostly as today we will learn about time measurement. That is chapter 3. But as I asked you yesterday, if you want to make a revision about chapter 1 and chapter 2, so and also asked by your friends, okay, you want to do a revision in topic subtopic 1B and 1D. Okay, so today I will recap some topic in chapter 1 and chapter 2. Okay, and then after that we will continue our lecture in on chapter 3. So if we still have a time. So if not, we will continue our lecture on chapter 3 next week. Okay. So today we go in chapter 1B, that is astronomical coordinate system. Okay, wait. Present. 1B and 1D. Okay, I will use the same slide as our as previous lecture. Okay, slide yang dah diconting-conting ni lah. Okay, so uh, we will go through about astronomical coordinate system again. There is topocentric and geocentric. Okay, before we go to the geocentric, topocentric and geocentric, I want to make sure you know about the coordinate system. Okay, what is coordinate system and why we have a coordinate system on the outer space. Okay, so as you know, the coordinate itself mean by location. Okay, location. Okay, so if we call, there is coordinate. Coordinate itself, coordinate itu sahaja. Okay, tanpa perkataan system. Tapi if we combine coordinate with system, there is it's mean by reference system used to define the location of points. What is mean defined by define location of point is mean by there are various type of coordinate system. Okay, terlalu banyak jenis coordinate system ni. Okay, every country they have their own coordinate system. Okay, so coordinate system tu that's mean a reference system used to represent the location of point which which we call it reference system is mean by it defined by their own criteria. Okay, their own criteria. That is coordinate system. So coordinate system defined by their own criteria. For example, it framework. Okay, which it is it from geographical ataupun planimetric. Okay, if geographical, it means our position is our position is origin by center of the earth. Okay, kalau kita gunakan perkataan planimetric, it means we projected onto a earth surface in 2D. Okay, secara two dimensional. So kalau two dimensional ni is adalah kepada x dan y lah, north and south. Okay, so it also defined by unit measurement, either in degree, minute and seconds ataupun in the meter. Okay, meter, kilometer, metric system. And then coordinate system have their own map projection. Okay, what is mean map projection? Bagaimana kita jadikan the sphere surface to secara 2D. So there are some mathematicals in map projection. So dia akan berbeza-beza lah. So setiap sistem koordinat is not the same. So in astronomical, okay, before we go to astronomical, I just generally state the position on the Earth. One of the type coordinate system, okay, that we locate point on the Earth. There is we define our location based on latitude and longitude. Okay, so we can see di sini latitude, longitude. Okay, which latitude is mean by angular distance. When we say angular distance, the measurement unit is degree, minute and second. Angular distance to the north or south from equator along the meridian. So if you can see this diagram, this image, okay, yeah, so sorry. Okay, so this is latitude and longitude. Which one latitude? Which one longitude? Okay, the red longitude or latitude? Which one latitude? Which one longitude?
Red longitude.
Okay, the right one is longitude.
Green one is latitude.
Okay, this is longitude. Kena ingat ni. Okay, saya tak menggunakan as I always mention in diagram, I usually use symbol. Okay, kamu kena ingat lah. Longitude, which one longitude, which one latitude. After this, we go to the new chapter, chapter 3. Okay, kita akan selalu guna longitude. Okay, longitude rather than latitude. In chapter 1 and chapter 2, you always see the latitude, but in chapter 3 saya akan banyak kali sebut longitude. Okay, so the longitude is angular distance to the north or south from equator along the meridian. Okay, the latitude we start with Earth equator. This is not celestial sphere, but on the Earth. Okay, you must different between celestial sphere and Earth. Okay, so if you can see here, I put the North Pole and South Pole and divide by Earth equator. And we have two hemispheres, North Hemisphere and South Hemisphere. Okay, what is latitude? Latitude is angular distance starting from our Earth equator to the position on the Earth. Okay, this is latitude. So how we measure latitude? From the center of the Earth and to the location of the point. Okay, Earth equator will be 0 for longitude, and we will measure angular distance from Earth equator as 0 to the location of point. Here, this one, angular distance. Okay, there is latitude. Ini kita akan refer kepada kalau ikut framework is geographical framework. Kita ikut based on center of the earth. So next one is longitude. Angular distance along equator to the east or west from prime meridian, Greenwich meridian. So this is Greenwich meridian at UK, and the angular distance we measured from longitude from Greenwich meridian to the location of a point on Earth surface. Ini adalah angular distance. If you can see, this is angular distance starting from the Greenwich meridian to the center of the earth. Okay, and then we go to the location of a point. Okay, for example, this is point A. So we will have longitude A. Okay, so any question in this slide?
No,
Madam,
madam.
Yeah.
I'm wondering, why did they use Greenwich Meridian as a reference of that longitude?
Because from on the earth, okay, we have a start point. Okay, so our start point is in UK. So our first creation of the longitude is start with will be at UK, and then it start with uh uh after we create the coordinate system, so we know dia adalah bermula daripada kajian yang dulu. So we start to create the coordinate system. Okay, they must have the reference. So to locate our position, we need two parameter. If we use only one parameter, okay, if we use one parameter, okay, so it cannot define our location. For example, point A. So if I use the latitude of A only, okay, I told you my latitude as 30 degree. For example, okay, my latitude is 30 degree. So sepanjang-panjang along this circle, we have the same value, the same value of latitude. That is 30 degree. Okay, so we need to another parameter. Okay, before we create the there is ini adalah bermula daripada yang dulu. Okay, so untuk bermula daripada yang dulu, they need two parameter, which one they create another longitude, another parameter. Okay, itu dulu maksudnya creationnya adalah daripada UK. That's why they want start from Greenwich meridian. Okay, they want start daripada satu garisan yang melalui United Kingdom. Okay, UK to create another parameter for longitude. Okay, menjawab soalan tak?
Jawab.
Boleh,
Jawab,
Jasmine?
Boleh.
Okay.
Thank you,
Okay.
Madam.
Okay. So there is latitude and longitude. After this, I will search the history for latitude and longitude lah for further information. Okay. So this is position on the earth. Okay, we go to the saya tak nak lah mendalam mengenai coordinate system on the earth, because we learn about celestial coordinate system or astronomical coordinate system. Okay, saya just nak recap kembali what is astronomical coordinate system. Okay, so astronomical coordinate system, also known as celestial coordinate system, is mean we want to locate the celestial body. Okay, we want to define the coordinate of celestial body or locate the location of celestial body on the outer space. Okay, when I mean the on the outer space, we have the celestial sphere, and we we make the celestial body will start on the celestial sphere. Okay, so same as system coordinate yang lain. For example, that I mentioned before, system coordinate system ni, they have their own. When we say the coordinate system, they have their own criteria that define that coordinate system. Okay, apa yang saya kata, they have their own yang menyatakan itu adalah coordinate system adalah khas daripada dia punya rujukan, from dia punya origin. For example, coordinate system in the celestial coordinate system, we have topocentric coordinate system and geocentric coordinate system. Okay, dalam setiap in each topocentric and geocentric ni, they have their own framework. They have their own parameter that define coordinates, that define the location of celestial body. Dia ada framework dia. Kalau kita tengok balik, kita recap balik what is topocentric coordinate system. Topocentric coordinate system, we locate from observer position, yang mana kita tentukan kedudukan uh, the position of the celestial body is based our position, observer position. Okay, that's mean on the Earth surface. Okay, while geocentric coordinate system, we define, okay, we know the position of celestial body is based on center of the Earth. So ini saya tak nak tahu explain mengenai ini, tapi we go terus kepada perbezaan between topocentric and geocentric. Okay, so here okay, saya masukkan di sini. Saya terus kita recap again about the topocentric and geocentric. Design kosong. Okay, here. Okay, I will create this is the same. I will create two image, okay, two diagram, but the both is the same Earth and the same position on the Earth. Okay, so this is Earth, where we have Earth equator and North Pole. Macam mana? Okay, ini. Okay, so this is Earth equator and this is North Pole, South Pole. Okay, so I will put this is Earth equator and North Pole and South Pole. Okay, this is North Pole, South Pole, and equator. Okay, katalah, okay, there is an observer on the Earth. Okay, here I just put the point that is mean the observer. Okay, so ini adalah observer. Observer observe the sun. Okay, so observer ni dia akan ada position dia sendiri, latitude and longitude. So I will show you this is latitude. Warna merah lah. Okay. I'm so sorry. Okay. Okay, nah. So this is the Earth and the position of the observer. So the position of observer is mean that he have their own coordinate, latitude and longitude. So I just put the latitude. This observer. Okay. So kita nak bezakan. We want to differentiate between topocentric and geocentric, and then we will combine the topocentric and geocentric. Okay. Okay. So this is topocentric. So this is geocentric. Okay. So biasalah kalau saya lukis bumi ni, okay, usually I want to look observer yang berdiri instead of north pole and north pole and south pole yang vertical. Okay. Saya groupkan dia, and then seperti biasa I like to show you in the position of observer yang berdiri. Macam ni. Okay. Sebab apa? We will observe, and then the parameter that we observe is from our location. Okay. So some people they like gambar macam ni. Bumi ni north pole and south pole vertical, menegak. But for me, I like to show in observer yang berdiri. Okay, because we observe the star, celestial body. So I will put the same image as geocentric. So we can show the difference between the geocentric and topocentric. Okay, here. Okay. Okay. So we go to topocentric, the definition of topocentric. Okay, we will have our celestial sphere. Okay, where is the center of our celestial sphere for topocentric coordinate system? What is the center of the celestial sphere? What is center of celestial sphere for topocentric coordinate system? Where is it? Okay, so the observer is the center of the celestial sphere. Okay, so the is okay. So the center of celestial sphere will be the observer position. So we define the position of the star on the topocentric coordinate system is based on the observer position. Okay, so we insert when we have the celestial sphere. So we have our location, observer location. So we will have, when we have the observer on the Earth, so we have our horizon. So we create our horizon here. Okay. One, we have our horizon. Oh, kena kecilkan sikit ni. Okay, saya akan fokuskan kepada topocentric sahaja. Dekat center ni. Okay. So, when we have our observer, we have our horizon. Okay, above the observer head, we have a point of kita akan ada apa? Zenith. Okay. Kena ingat yang ni benda yang sama. Okay. Saya bagi tengahkan dia sekejap. Okay. Sekejap Okay. So we have zenith and below the horizon. Below the observer. Nadir. Okay. So this one is nadir. So saya buat color lain lah supaya hijau. Okay, this is celestial sphere for the topocentric coordinate system, which our position the position of celestial body are defined by observer position. Okay, that means the center of the celestial body will be the observer location on the earth. Okay, maksudnya center ni, titik pusat of celestial sphere ni, tengah-tengah dia akan uh, tengah-tengah celestial body ni, tengah-tengah di dalam tengah-tengah celestial sphere tu, itu adalah titik observer. Okay. So bila kita ada So bila kita ada horizon, we have zenith and nadir. Of course, we have every observer will have their own cardinal point. Okay, what is mean cardinal point adalah arah mata angin tu lah. Okay, so the cardinal point is north, south, east and west. Okay, example this is east and west. Okay. So if we want to locate the position of the sun, okay, for example, the sun that we use to in our practicals, okay, in your practical we'll observe the sun. There is one of the celestial body. So kita akan apply menggunakan matahari, bintang matahari or any ni adalah celestial body. So this is our sun. Okay, kita refer balik what is mean by topocentric coordinate system. Ini. Okay. To describe the position of celestial body based on the observer position. Our position is unknown, so we must assume a position first. Okay, macam yang saya tunjuk tadi, there is latitude. Okay, so how we want to know the position of the location, that is coordinate system, latitude and longitude. For the observer, we will use the separate observation. Okay, what it means separate observation? We will do by traversing GPS or any other observation. Okay, to have the location coordinate on the on the Earth. And then we will have our solar observation. Okay. So this is our position is unknown. So we must assume a position first. Macam yang saya tunjuk tadi, kita ada latitude, position of coordinate of observer on the celestial on the Earth surface. And then what is the parameter that define the celestial body? Azimuth and altitude. Okay, kembali balik. Kita define azimuth and altitude. Okay, kita define matahari ni with the azimuth and altitude. Parameter yang digunakan adalah azimuth and altitude. Okay, azimuth and altitude. Okay, what is azimuth? This is symbol for azimuth and altitude. What is azimuth? What is azimuth? Azimuth.
North to east, to south to west, and back to north.
So azimuth is the angular distance. Okay, the angular distance that we measured from north. Okay, we measured from north. Secara clockwise, arah jam. Okay, from the on the observer horizon to the celestial body. That is azimuth. Angular distance starting from north, measured clockwise, okay, to the celestial body. What is mean by measure clockwise to the celestial body? Okay, I will show you. So we will have the circle that cross to the celestial body. We call it as altitude circles. Okay, so this is altitude circles. Saya guna simbol dia tahu. Okay, and then if you want to define the azimuth, okay, ni this is azimuth. Warna biru. Take warna biru. Warna biru dah ada. Okay, warna merah. Warna merah pun dah ada. Okay, so this is position of celestial body. Okay, what is mean by azimuth? We start from the north. Okay, why we start from the north? Because our north is 0 degree for azimuth. North point is 0 degree for azimuth. Okay. Any value on the coordinate, we will have our reference, our starting. Okay, kita akan ada kita punya starting point kita. Kita tak boleh start daripada mana-mana. Even kamu lumba lari pun, kamu akan ada starting point kamu, iaitu 0 meter. Okay, sehinggalah 100 meter, for example. Okay, 0 meter hingga 100 meter. Takkan kamu start daripada mana-mana and then kamu stop sehinggalah 100 meter. No. Bila kita starting with lumba lari, for example, akan start, semua peserta akan start dengan 0 meter. Macam tu juga kalau kita nak measure azimuth, altitude, declination, right ascension, we will start with our 0 meter or 0 degree. Okay, so for azimuth, our 0 degree is from our north. Okay, this is azimuth. Ini adalah azimuth. So for starting 0 degree untuk azimuth, the starting dia adalah north. Di mana kita merujuk, okay, we refer to the celestial meridian. Okay, why celestial meridian? Because celestial meridian is 0 degree, okay, 0 degree from 0 degree for azimuth. This is celestial meridian. Okay, the circle that run through zenith to nadir. Okay, back to zenith, tetapi mestilah melalui titik cardinal north and south point. Okay, ini adalah celestial meridian. Okay, this is celestial meridian. That's why azimuth we will start with the celestial meridian. Okay, maksudnya we have our reference plane to start our nilai, our value. Okay, for azimuth we start with celestial meridian. For altitude, what is mean by altitude? What is mean by altitude? What is mean by altitude? Apa yang kamu tahu mengenai altitude? Apa maksud altitude itu sendiri?
Height.
Okay, height. And in astronomical coordinate system, in astronomical coordinate system, what is altitude? What is altitude? Jangan lupa.
From the observer to the zenith.
Hampir tepat. Kamu nak assessment ni?
Angular distance
Angular distance
measured from zenith to the celestial body.
measured from zenith to the celestial body. Okay, betul ke yang lain? Angular distance that measured from zenith to celestial body.
Madam, angular distance measured from the horizon and the celestial body.
So altitude. Macam mana ni kamu dah nak exam dah hari Sabtu ni? Okay. So angular distance, azimuth is angular distance. Okay. Where altitude, the value of altitude is determined from horizon. Our horizon will be 0 degree for altitude. Okay. So maksudnya our reference 0 degree for altitude is at horizon. Mana-mana tempat yang berada di atas horizon, okay, duduk pandangan kamu di atas horizon, we will start with 0 degree altitude for celestial body. Okay, untuk tentukan kedudukan matahari atau untuk tentukan to determine ataupun to define the position of the celestial body, our altitude will start with 0 degree at horizons. Okay, ni 0 degree at horizon altitude. Okay, 0 degree celestial meridian, 0 degree for starting azimuth. This is altitude. Okay, this is altitude. So, ini yang dikatakan, ini yang dikatakan topocentric coordinate system, where it from the framework for topocentric coordinate system, we start from the center of the celestial sphere, which is observer position, okay, observer location, and the parameter defined by the celestial body are defined by azimuth and altitude. And our azimuth and altitude have their own reference plane. Okay, so azimuth we get from celestial meridian, where celestial meridian is 0 degree to determine the azimuth, 0 degree to 0 degree for azimuth, and horizon is 0 degree for altitude. This is topocentric coordinate system. Faham And yet still ada yang tak faham apa itu celestial meridian. Okay. So dia fikir, Madam, why this is celestial sphere, right? Ya, keseluruhan ni, permukaan ni adalah celestial sphere. Okay, celestial meridian is only a great circle. For example, you have a limau orange ataupun you have a ball. Okay, kamu pegang ball tu ataupun kamu pegang limau tu, okay, ambil marker, lukis bulatan di atas limau tersebut. Okay, satu permukaan limau, the whole orange surface, okay, satu permukaan limau tu, itu adalah celestial sphere. Okay, kamu ambil marker, kamu buat bulatan di atas permukaan limau, itu adalah celestial meridian. Okay, so dalam celestial sphere, dia banyak bulatan dalam tu. Dia bukannya satu bulatan, just celestial meridian. Tetapi dia terlalu banyak bulatan. Dia boleh jadi horizon pun bulatan, celestial meridian pun bulatan, celestial equator pun bulatan. Apa lagi bulatan untuk di atas celestial sphere? Apa lagi bulatan yang ada di atas celestial sphere? Celestial meridian, horizon. Apa lagi? Kalau kamu tengok kat sini, apa benda yang boleh?
Celestial
Altitude.
equator.
Celestial equator, altitude circle, prime vertical. Dah lupa lah tu chapter 1. A. Tengok balik definisi dia. Okay. In chapter A, you can see I mention point, line, circle, a great circle. Okay. Kalau zenith and nadi, bukan bulatan. Dia hanyalah point on the earth, di celestial sphere. Okay. So kat sini saya tunjuk balik apa itu topocentric coordinate system. Altitude, azimuth. Lukisan saya ni tak beberapa nak ni lah kan, nak cantik sangat. So kita tunjuk yang cantik sikit. Okay. Okay, nampak tak saya punya simulator ni? Okay, nampak Okay, this is my cursor. Follow my cursor. Follow my cursor, the red one. Okay, okay. So this is we can call it is part of topocentric coordinate system. Okay, the grey one ni, yang berwarna grey, transparent grey ni, ini keseluruhan celestial sphere ataupun kamu katakan sebiji limau. Ini sebiji limau. Okay, keseluruhan ni adalah celestial sphere. Okay, so there is observer the center of the celestial sphere. So it means the origin of celestial sphere, the origin for topocentric coordinate system is start from observer position of the point on the earth. Okay, so when we have our observer, automatic on the observer head, we will have a zenith. Okay, below the observer feet, we will have a nadi. Okay, and you see here, zenith, nadi. Yang ini sebab kita boleh pusing-pusing sikit. Yang saya punya lukisan biasa sahaja. Okay, tak boleh pusing-pusing. So, seperti biasa, observer will stand on the horizon plane. Can you see horizon plane? Bermaksud ini adalah bulatan. Horizon adalah bulatan. Horizon bulatan. Apa lagi? Prime vertical pun bulatan. Celestial equator pun bulatan. Okay. Cuma the difference between horizon and celestial meridian, celestial meridian, bulatan dia sama ada dia tunjuk dalam bentuk satah, okay, dalam bentuk plane, okay, horizon plane. Tengok ni dia tulis horizon plane, okay, dia berbentuk satah, bermaksud dia ada permukaan dia. Okay. When we great circle, bulatan. Tetapi sekiranya kita sebut circle plane, dia adalah secara satah, dia ada permukaan. So, if you can see here, this is horizon and we have the celestial meridian. That great circle that run from zenith, nadi, and back to zenith, but through the cardinal point, north and south. Itu adalah celestial meridian. Okay. Kalau tengok balik orange, buah orange, kan saya katakan buah orange yang kamu lukis satu great circle, you draw a great circle on the orange, okay, atas kulit orange tu, okay, itu adalah celestial meridian. Tetapi mestilah melalui north and south point. Bulatan di atas celestial sphere. Ingat je, buah orange, satu keseluruhan permukaan buah orange tu adalah celestial sphere, dan you draw a circle on the orange, is mean by celestial meridian. Dia bermaksud celestial meridian di situ. Itu hanyalah bulatan. Keseluruhan permukaan itu adalah celestial sphere. Okay? 90 degree from celestial meridian. Kalau kamu perasan ni, ada garisan ataupun circle from zenith to east to ni to nadir ni, bulatan yang kita kosong-kosongkan dia tak mengganggu kan. Okay, so if you can see the bulatan, the grey one, okay, the light grey, bulatan sini, zenith, east, nadir, and go to west and back to zenith, this is prime vertical. Bulatan juga. Okay, dia berbentuk bulatan juga. Okay, prime vertical ini. Itu adalah bulatan. Dekat sini ada berapa bulatan? How many great circle on this celestial sphere? How many great circle on this celestial sphere? How many? Berapakah great circles? Maksudnya berapakah bulatan yang berada dalam celestial sphere yang saya tunjukkan ini?
4.
4. 3. So macam mana boleh jadi 3, macam mana boleh jadi 4? 2. So macam mana boleh jadi 2, macam mana boleh jadi 3, macam mana boleh jadi 4? Okay, apa yang 2 tu? What is the 2? 2 great circle. Okay, first is horizon plane and second is horizon plane. So Jasmine sebut 4 tadi.
Horizon plane.
Horizon plane.
I can't remember the name. From zenith to nadir.
Zenith to nadir, okay.
And then I also include the celestial meridian.
Okay, horizon plane is first great circle. Second,
celestial meridian. And
celestial
then
meridian. Third,
I'm including the great circle.
you including okay, horizon plane, macam apa? Tadi siapa jawab? Mubin. So Mubin said horizon plane and celestial meridian is a great circle. Yes, that is a great circle, bulatan. Okay. So saya tanya berapa bilangan bulatan yang kamu boleh nampak yang berada di sini? Okay. So first is horizon plane, second is celestial meridian, third is prime vertical. Yes. Yang dari? Daripada zenith ke east tu apa dia kita panggil? Kat sini dah tak ada label. Nakkan label kan? Tak boleh. Saya tutup semua label. Saya baru sebut je tadi. What is the great? No, there is no celestial equator in here. Ini adalah topocentric coordinate system. Saya baru pergi yang basic. Hari Sabtu nanti kamu akan ada first final assessment. Kita ada celestial meridian. Ya, saya sebut tadi celestial meridian, horizon plane. Okay, what is another one? For me, there are 3 great circle on this surface and on this celestial sphere.
Prime vertical.
Prime vertical. Okay. bulatan ataupun great circle that run from zenith to nadir and back to zenith, but they go through east and west point. Zenith, east, nadir, west and back to zenith. Yang ini saya jarang sebut. Prime vertical ni saya jarang sebut. Tapi tak bermaksud dia tidak wujud. Okay. So, kalau saya buat macam ni. Okay. Contohnya kita ada, kita observe the sunrise. Okay. Sunrise about, azimuth is about 92 degree. For example lah, 92 degree. And, 95. Kok sangat 100. Bagi nampak sikit. Okay, 100 and altitude is in 30 degree. Okay, how many great circle in here? Okay, kamu kena tahu great circle apa yang berada di dalam ni. Kita akan ada horizon plane, kita ada celestial meridian, kita ada prime verticals. Saya ada masukkan lagi satu great circle, apa benda? Apa dia? Apa dia, Bubi? What is that? Never mind. Okay. One more. Apa dia? Ayat ni saya selalu repeat. I think every lecture, I always say these circles, kecuali in chapter 1C. Starting from 1A to 1B and 1C, 1D, 2A, 2B, 2C. Only one chapter I not brief about these circles. What is that? Ni nampak tak bulatan ni? Zenith, nadir, tapi cross kepada celestial body. Ini kita panggil bulatan apa? Altitude circle. That is part of great circle on the celestial sphere. Okay, ingat. Zenith, nadir, point. NCP, SEP is a point on the celestial sphere. Horizon plane, meridian, apa lagi? Celestial meridian, prime vertical, altitude circle, declination circle, apa lagi? Celestial equator. Itu adalah a great circle, bulatan yang berada di atas celestial sphere. Example, you have limau. Again, saya bagi contoh yang sama sahaja, buah limau. Sebab nanti mungkin kamu boleh nampak sikit buah limau tu. Okay, buah limau tu, you have atas dia tu ada top dia tu kan. Ada kepala dia dengan yang bawah tu kan. So, anggap je yang top and bawah dia tu, okay, adalah zenith and nadir. Kamu lukislah berapa banyak pun bulatan yang berada di atas limau tersebut, tapi mestilah run through zenith and nadir ataupun run through NCP and SCP. Itulah bulatan-bulatan yang berada di atas celestial sphere. Yang tadi yang saya sebut tadi. Okay, horizon plane, meridian, celestial meridian, prime verticals, apa lagi? Altitude circle, declination circle, celestial equator. Okay, mesti ingat semua bulatan-bulatan tu sebab all the great circle is important for your calculation, for you to define the position of the celestial body. Okay, itu adalah topocentric coordinate system. Okay, so we go to geocentric coordinate system. Dah 948 dah ni. Okay, we go to geocentric coordinate system. Sama juga kita akan ada bulatan celestial sphere. We will have the bukan bulatan lah. Okay, we akan ada permukaan berbentuk sfera. Salah pula dah. Oh yeah, I'm so sorry. Lupa nak ni attach balik. Apa jadi? Okay. So difference with geocentric coordinate system. Apa pula saya ambil ni? Okay. Okay. So different from topocentric coordinate system, geocentric coordinate system, our origin ataupun our center of the celestial sphere is based on center of the earth. Bermaksud titik center of the celestial sphere, bermaksud kalau kamu potong 5 kan, titik tengah aja tu it will dia akan berada di center of the earth. So it is celestial sphere for geocentric coordinate system. Tengok apa perbezaan dia. Kamu tak boleh samakan tau. Okay, tadi kita katakan dia is celestial sphere for geocentric coordinate system. And to define the position of the celestial body, the parameter that we define to the celestial body, apa parameter yang kita define untuk geocentric coordinate system? Celestial body based on geocentric coordinate system. What is parameter that we use to define the position of celestial body based on geocentric coordinate system? Apa dia? Yeah, center of the earth, the parameter that used to define the position of celestial body. What is that? No, that is our reference to define the parameter. For example, X, Y, latitude and longitude. Apa lagi? North, east. So, for geocentric, apa dia? Declinations and RA. Okay, ini parameter. This is azimuth altitude parameter to define the position of celestial body. Okay, tetapi to define azimuth, we need a reference for kita perlukan reference to define the azimuth. What is mean by reference? There is 0 degree, starting of 0 degree for azimuth. So kita start 0 degree for azimuth is from celestial meridian. Macam tu juga geocentric, kita akan ada the parameter that define the celestial body. Matahari yang sama kita tengok adalah kita refer kepada declination and RA. Maksudnya kedudukan ataupun position of celestial body. Okay, where is the position of the sun? So we can tell the observer, okay, the declination of the sun at the RA of the sun is at so kita akan tahu kedudukan matahari. So sama juga dengan latitude and longitude. So this is celestial sphere. So the origin for celestial sphere is center of the earth ataupun the starting titik the center of the celestial body, okay, is the center of the earth. Maksudnya kita punya titik pemula dia. Okay, kita define kita punya celestial body based on center of the earth. So bila kita ada geocentric, kita punya parameter is declination and right ascension. Okay, bila kita nak define declination and right ascension, so kita tengok what is mean by declination. Declination is angular distance starting from celestial equator. Starting from celestial equator. So we want to define, we want to measure declination. We must know the celestial equator. Kita nak define declination ni, kita kena tahu dulu celestial equator tu di mana. Kalau kita tak tahu nak start 0 degree from where. Faham tak? Dapat tak? Dapat Okay. So bila kita perlukan celestial equator, apa itu celestial equator? Bulatan atau bulatan that coincide with Earth equator. When we extend the circle of equator until it reach to the celestial sphere, okay, we call it as celestial equator. So bulatan yang bersama-sama dengan apa kita panggil ni? Earth equator. Okay, dia akan bersama-sama dengan Earth equator. Apabila kita ada Earth equator, automatik kita akan ada NCP and SCP. Okay, that is 90 degree from Earth equator. So bila kita ada Earth equator, bila kita 90 degree from celestial equator. Kenapa saya ingat Okay, so macam mana kita nak locate selain from celestial equator, we can locate the point of NCP and SCP. NCP will be above on North Pole, SCP will be above on South Pole. Dia akan berada di atas North Pole and South Pole. Okay, tengok kat sini. So, this is NCP, this is SCP. This is celestial equator. Okay, so kedudukan matahari adalah sama. Itu buah kan? Saya letak sama. Contoh ni, sini Okay, kedudukan matahari adalah sama sini. Saya letak sama. Okay, so to define the geocentric coordinate system or to define the celestial body based on geocentric coordinate system, the parameter that define the celestial body is declination and RA. So we go first to declination. So what is declination? Declination is angular distance starting from celestial equator to the celestial body. So saya lukis dekat sini. Okay, satu bulatan that cross to the Okay, point dia adalah berbeza. Okay, so starting from celestial equator, C is celestial equator. There is the point of the celestial body. So declination is angular distance starting from celestial equator, where celestial equator for declination is 0 degree to the celestial body. Okay, this is declination. Nampak? So itu adalah declination. You want to create declination. So manakala RA pula, right ascension. Okay, right ascension is start the distance from equinoctial polar. Ni equinoctial polar. Equinoctial polar. Maksudnya equinoctial polar ni is starting 0 degree or 0 hours. Okay, selalunya kita akan sebut dalam hours. Boleh sahaja sebagai degree. Tapi we will convert to hours. RA ni bacaannya selalu dalam hour, minute and second. Dalam bentuk jam. So we starting with 0 degree. Okay, 0 hours to the celestial body. Okay, contohnya. Macam mana kita nak tahu equinoctial polar tu dari mana? Okay, saya bagi contoh ni equinoctial polar adalah hasil daripada color. Hijau dah biru. Biru pun banyak dah. Okay, kuning. Okay. The equinoctial polar, okay. Okay, macam mana equinoctial polar? Okay, equinoctial polar terhasil equinoctial polar terhasil, okay, from the intersection between celestial equator to the from intersection between celestial equator and ecliptic. This is ecliptic. 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 What is ecliptic? Ecliptic is laluan matahari. Okay. So hasil daripada intersection between celestial equator and ecliptic, we will have a equinoctial polar. There are two equinoctial polar. One is vernal equinox, next is autumnal equinox. So our measurement for RA will determine starting from vernal equinox, starting from vernal equinox. Warna apa pula saya nak cari ni? Okay, warna ni orange tak kita nampak, warna hijau. Saya ambil warna hijau. Okay, so this is hasil perselangan ni, the intersection between celestial equator and ecliptic, that is equinoctial polar. So saya letakkan sebagai ni tanda starting of equinoctial polar. So equinoctial polar starting from his starting from ni, equinoctial polar is 0 hour for 0 hour to measure RA. Okay, so starting from 0 hour, okay, dia bergerak, okay, yang dikira daripada secara eastward, that measure eastward to the celestial body. Okay, 1 jam, 2 jam, 3 jam, 4 jam, 5 jam, 6 jam, sampailah kita bertemu dengan celestial body. Ini adalah nilai RA. Okay, boleh tak? Dah banyak sangat lukisan.
Boleh, madam.
So this so another great circle is ecliptic. Okay, satu lagi great circle yang kita boleh katakan adalah ecliptic. Okay, so saya share satu again saya akan share simulator ataupun demonstrator for geocentric coordinate system. Saya akan share ni supaya boleh nampak lah. Okay, kalau tengok yang ni kosong. Okay, kalau tengok yang ni, okay, tadi kalau tengok gambar rajah tadi, okay, for topocentric coordinate system, you can see the center of the celestial sphere is the point on the earth, but on the geocentric coordinate system, the center of celestial sphere is the center of the earth. So above the north pole and south pole point, we will have this is north pole and south pole. Above the north pole, okay, on the celestial sphere, we will have north and south celestial pole. Ni north and south celestial pole. Okay, so saya tutup north and pole. And when we extend the circle of Earth equator, this is the circle of Earth equator, until to the celestial sphere, we will have the celestial equator. Kita extendkan, kita kembangkan bulatan equator tu sampailah mencecahi celestial sphere, kamu akan dapat celestial equator. So untuk declination, we starting from kata saya letak 50 degree kan. Okay, so kalau kamu tengok dekat sini, garisan warna merah ni, okay, garisan yang north celestial pole to south celestial pole is declination circle. Okay, kalau kamu tengok ni, dia is from celestial equator, saya letak kosong. Okay, tengok, okay, celestial equator is a reference, okay, reference ataupun starting 0 degree for declination. Okay, saya tambah 10. Saya tambah sikit-sikit. Okay, 8, 15, 26, 33, 42, nantilah 50. Okay, so itu adalah declination. Cuma gambar rajah ni dia tak menunjukkan daripada center of the earth. Berbanding saya punya gambar rajah yang tidak boleh bergerak, tapi saya tunjukkan dari mana bacaan 50 ni, 15 degree. Bermaksud starting from center of the earth to the intersection of celestial equator and declination circle, you will start 0 degree for declination and then until to the celestial body. Kalau dia berada pada south, dia akan berada negative 90 degree, berada di bawah ni. Okay, boleh nak? Okay, itu adalah celestial. There is declination. Okay, macam mana kita nak tahu starting of RA? So kat sini, kalau kat sini RA dia adalah 0 circles. RA dia. Okay, so RA dia, so kita tengok kita punya ecliptic. Ni. So this is our ecliptic ni. Warna purple ni, this is ecliptic. The intersection between ecliptic dan juga celestial equator, we start with 0 RA. Tengok ni, RA ni adalah 0 hours. Jadi kita akan kira daripada 0 hours. Tu kalau dia bergerak secara eastward, okay, katalah 5 hours. Macam ni, starting from ni, along the celestial equator. Kita akan sampai celestial equator. Okey, boleh tak? Faham? Faham?
Faham, Madam.
Okey, ini adalah separuh bulatan yang ada di atas geocentric coordinate system kan. Tapi tadi kita tengok topocentric coordinate system, kita nampak lagi separuh bulatan. Okey, bila kita combine semua-semua tu, so dia akan banyak bulatan di atas celestial sphere. Kamu kena pandai differentiate for each great circle. Kamu kena tahu differentiate untuk setiap great circle. Okay. Kamu kena tahu untuk differentiate untuk setiap great circle. Dan kamu kena tahu juga macam mana kamu nak locate. For example, contohnya soalan yang kerap juga keluar pada semester-semester lepas. Saya bagi tahu untuk the previous semester. Sometimes the question asks you to locate the position of the star based on geocentric or topocentric, ataupun dia combine geocentric and topocentric menjadi kepada satu sistem. Okay? Dia combine lukisan tu, dia minta kamu locate bintang tu based on the parameter given. Kalau dia bagi deklinasi, dia bagi altitude, dia bagi azimuth, okay, kamu kena combine the celestial sphere tu menjadi satu. Faham tak, menjadi satu? Maksudnya tak boleh ada dua celestial sphere seperti yang saya lukis ni. Okay, kamu kena combine jadi satu. Itu saya dah ajar dah previous from previous lecture, banyak kali dah saya tekankan bagaimana untuk locate the position of celestial sphere based on combination topocentric and geocentric. Sometimes the question asks for topocentric only. Sometimes the question asks for geocentric only. So make sure kamu study mengenai ini semua. Okay, chapter 1 hinggalah chapter berapa Chapter 2. Okay, sampai the last yang sebelum minggu kita cuti gawai tu. Okay, please study. Okay, even kamu ODL, tolonglah study. Kamu faham kan maksud saya kan? Apa maksud ODL tu kan? Ya, even kamu menjawab soalan secara not face to face, kamu tak perlu pergi ke exam hall. Okay, kamu jawab from your room, please study. Okay, masa bukannya diberi banyak pun, 2.5 jam sahaja. Okay. Okay, so itu sahaja. Ada soalan? I'm so sorry cannot tak sempat untuk kita cover mengenai 1D, tapi make sure kamu study semua tu. Okay, study semua-semua tu. Okay, so itu sahaja. Any question? Any other question? Ada tak?
Ada,
No.
madam.
Okay, so okay.
Time private WhatsApp ke Google Class nanti?
Itu nanti saya akan maklumkan kemudian. Tapi yang saya tahu kita akan secara ni lah, bukan face to face je lah. Okay, kaedah tu nanti saya inform balik. Okay. So please make sure you available on that day and make sure your internet tak ada masalah and make sure you can submit your paper on time. Okay. Jangan waktu last sekali tu baru kamu nak submit. Okay, please kata kena pukul 10.30, kata habis pada pukul 10.30, dia bagi 2 jam kan. Sepatutnya kamu punya jawab tu hanyalah 1 jam sahaja. Untuk 1 jam setengah sahaja. Selebihnya kita anggapkan kamu nak submit. Kamu memerlukan masa untuk submit. So make sure kamu boleh manage your time waktu menjawab. Every semester I will have problem. Madam, I cannot send my answer. Sebab apa? Ada sense selepas waktu menjawab. Okay? Kita akan bagi dalam waktu tersebut. Kamu kena send pada waktu tersebut. So maksudnya bukannya 10.30 kalau habis 8 hingga 10.30, kamu habis 10.30. No Kamu bukan habis 10.30. Maksudnya last untuk submit adalah 10.30. After 10.31 tu dah tidak boleh submit jawapan. Sebab soalan tu hanyalah refer kepada 1 jam setengah, bukan 2 jam setengah. Lagi sejam tu, kita anggapkan kamu ambil masa untuk submit di mana internet kita pun tak adalah apa? Tak adalah kita panggil apa? Tak adalah laju, tak adalah kukuh sangat kan. Macam kamu student duduk kat sana kena compete with each other tu dapatkan internet kan. Okay, siapa yang gunakan internet college, siapa yang gunakan internet sendiri, alhamdulillah lah. Itu pun kena sentiasa top up. Okay, so boleh nak? Saya bagi tahu siap-siap ni. Saya tak mau dengar dah any reason about madam saya tak dapat submit. Bila habis sampai 10.30 maksudnya it mean 10.30 is last you tekan tu submit. Bukannya 10.30 baru nak tulis nama, nak ni baru nak submit. No, saya tak akan terima. Okay, itu sahaja. Terima kasih. Dah 10 suku ni saya tak tahu kelas apa pula teks ni. Okay. Okay, Assalamualaikum. Boleh bersurai. Group A still ada kelas.
Waalaikumsalam, madam.
Salam, madam. Thank you.
Salam, madam. Thank you.